Hello everyone, my name is Emiliano Larach, and today I'm going to be walking you through my lab number 2 for physics, which is titled Lines of Charge. First, I'm going to do a little bit of introduction with key ideas, and then the computational model that I use. I'll include some code snippets, the output of my code, and some discussion questions that refer to the accuracy of this lab. First of all, on key idea we have Coulomb's law that describes the electrical force between two objects. Then we have the concept of electric field, the force due to gravity, which we simplify as minus mg. Concept of line charges we will be going over on this lab, where we split an object into multiple charges to better approximate it rather than using just a single point charge. We are also going to use the definition of electric field superposition that lets us add multiple electric fields without each one interfering with one another. Some relevant formulas that are very self-explanatory are the Coulomb's law, are the electric field for the point charge, for the charged rod in one of its extreme conditions, and also the force due to gravity. So for our experimental setup, we set a tape B that was above and a tape A, and we measured the distance we had to bring the charged tape A to tape B for it to float. We also recorded the mass, the length, and the width of the tape to be able to do our calculations. This was based in our previous lab, and in our previous lab we found the charge of tape B. But on this lab, we are not going to approximate it as a point charge, rather as multiple charges distributed over a line. So first, to calculate the electric field, we just use the electric field formula, which is this is very similar to our previous lab. And the important part is in the next part of my code, where I approximated the tape. I split up the tape into multiple charges. You can see here my n is 150. I chose 150 like as a very high number to make sure my values were not changing anymore, and I found 150 to be a good number. And this is a for loop, so I divided my tape into 150 pieces, and I calculated the electric field gave by each one of those points on the other tape. So I calculated the electric field on the top by the bottom one. My code output, after calculating this, you can see all of the arrows, these are, if we count them, we're going to find 150 arrows. We found that the magnitude of the electric force is 1.96, and this is in coulombs, and 1.96 times 10 to the negative 3 coulombs, and the magnitude of a gravitational force is 2.01 times 10 to the negative 3 newtons. And our results, I calculated Q by hand before doing my experiment using the rod approximation, and I got 8.28 times 10 to the negative 9 coulombs, and our magnitude of electric force and magnitude of gravitational force that we got from our experiment. This Q I was able to get by setting equal force of gravity by force electric, because these are the two forces that counteract each other. So we have force of gravity going up and force of gravity going down and electric force going up, and by setting them equal we are able to identify our Q. Then we just assume that our tips have evenly distributed charges, and we can see a difference between the two of our labs. In our first lab, this is a snippet, a screenshot from my lab, I found that Q on B was 1.857 times 10 to the negative 9 coulombs, and now we have this result, which is 8.28 times 10 to the negative 9 coulombs. So this difference is because of the different approach we have to it. Previously we were treating as a point charge, and now we're treating as multiple charges, which is much more realistic. And this takes us to the next question, is why do these estimates differ? Which value is more likely to be closer to a real value? and the distributed charge, the line charges, is way more representative of what's happening in real life. So that would be all for my lab. Thank you all for watching, and I hope you enjoyed it and I was able to explain the main phenomena for this lab. Thank you.